Today we are discussing about the topic problems based on linear differential equation with variable coefficient. Problem number 1. Solve x square d square plus 3xd plus 1 into y equal to sin of log x by x square. So this is constant problem, differential equation with variable coefficient. So first transform into constant coefficient differential equation by the substitution x equal to e power z, z equal to log x, and then operator form x dy equal to theta y, x square into d square y equal to theta into theta minus 1 into y. Here theta is operator, then theta equal to d by dz. This differentiation with respect to z. Now these values substitute the given equation, it becomes x square d square y equal to theta into theta minus 1 into y plus 3x3 replaced by theta y plus 1 into y is equal to, in all cases substitute log x by z x square by e power z sin z by e power z whole square. Now simplification, theta square minus theta plus 3 theta plus 1 into y. In all terms involving y, take outside y equal to sin z e power z whole square value e power 2z. Now simplification, theta square minus theta plus 3 theta plus 2 theta and constant term plus 1 into y equal to, in all cases the denominator value e power 2z, it moves in numerator e power minus 2z into sin z. So it is linear differential equation with constant coefficient. Constant coefficient means theta square coefficient 1, theta coefficient 2 and constant term 1. So generally the differential equation solution consists of two parts. The first one is complementary function, second one is particular integral. Then finally write complete solution. Then complete solution equal to complementary function plus particular integral. So we calculate one by one complementary function and the particular integral to find complementary function. That is complementary function short form CF. Here consider the LHS. Then operator substitute theta equal to m square plus 2m plus 1 equal to 0. Now factorize this quadratic equation, m plus 1 into m plus 1, that is sum of two root value plus 2, product of two root value plus 1, m plus 1 into m plus 1 equal to 0. So m plus 1 equal to 0 and m plus 1 equal to 0. So m equal to minus 1, m equal to minus 1, then m equal to minus 1 minus 1. So both are equal root. If two roots are equal, the complementary function CF equal to AZ plus B into e power AZ. Here A equal to minus Z. So the CF equal to AZ plus B into e power minus Z. The next find particular integral, that is PI. Here consider the arbitrary value. Here arbitrary value e power minus 2Z into sin Z. E power minus 2z into sin z divided by, so the LHS operator value theta square plus 2 theta plus 1. It is start from theta plus 1 whole square. So e power minus 2z into sin z by theta plus 1. Now simplification, in numerator product of two different functions exponential and trigonometric function. In this type of PI value, first take out the exponential function by the substitution theta equal to a, where a equal to exponential function on z coefficient value or x coefficient, that is minus 2. Here coefficient value minus outside the exponential function e power minus 2z into sin z by l theta equal to theta square plus theta plus 1 whole square, theta equal to theta plus a, here theta minus 2. Now substitute theta equal to theta minus 2, theta minus 2 plus 1 whole square e power minus 2z into sin z by theta minus 2 plus 1 minus 1 whole square. So evaluate this part only. Now expand in the denominator theta minus 1 whole square e power minus 2z into sin z by theta minus 1 whole square expansion theta square minus 2 theta plus 1. So this particular trigonometric function theta square equal to minus a square, here a value z coefficient minus 1. Now substitute sin z by minus 1 minus 2 theta plus 1. Here minus 1 plus 1 cancel. So remaining e power minus 2z by the constant of minus 2. So remaining value sin z by theta. So evaluate this part. We know that 1 by d stands for integral of dx and 1 by theta stands for integral of dz. 1 by d stands for integral of dx, 1 by theta stands for integral of dx. This becomes minus e power minus 2z by 2, then integral of sin z into dz. Now integrate the integral of sin x value minus cos x, then substitute pa equal to minus e power minus 2z by 2, is integration value minus cos z, minus minus plus e power minus 2z into cos z by 2. This is particular integral of given problem. Now finally write the general solution is y equal to complementary function plus particular integral. So complementary function value az plus b into e power minus z, and the particular integral value e power minus 2z into cos z by 2. And finally substitute z equal to log a, x equal to e power z. That a log x plus b into e power minus log x plus e power minus 2 log x into cos of log x divided by 2. We know that e power log x equal to x, e power minus log x equal to 1 by x, e power minus 2 log x equal to 1 by x square. This value applied here a log x plus b into e power minus log x value 1 by x, so divided by x plus e power minus 2 log x value 1 by x square cos of log x by 2 x square. So this is general solution or complete solution of given variable partial differential equation.